trigonometric function. Now before going to trigonometric functions, let us understand trigonometry. The word trigonometry is derived from the Greek word trigon and metron, and it means measuring the side of a triangle. So this is the basic understanding of trigonometry. The word, the trigonometry, is split and the explanation is given. Now we try to understand some ratios which are available in trigonometry. So we understand trigonometric ratios. For that we require a right angle triangle. Right angle triangle, and thus suppose this angle is right angle. We'll name it as ABC. So right angle triangle. So these are the sides and this is hypotenuse. Now if I take one of the angle other than right angle, say this angle C, I call it as theta. Then side BC becomes adjacent side. It becomes adjacent side. And the side opposite to theta is AB. It becomes opposite side. And this is hypotenuse. We write in short, hypo, oppo, adjacent. So this is adjacent side, opposite side, hypotenuse. Adjacent side is written as x, opposite side y, hypotenuse as r. Now it is not necessary that triangle should be ABC in this form only. It can be any triangle in any form. That is right angle triangle in any form. Right? Suppose I draw right angle triangle in this way. I mention theta here or somewhere else. I write PQR. Then also this side is adjacent, opposite, hypotenuse. So you can have different triangles, right angle triangles, and you can find out adjacent, opposite, hypotenuse sides, and then by using all these things and the help of Pythagoras theorem is also there. Using all that thing, we can find out the trigonometric ratios. So first we talk about trigonometric ratio. First ratio, say I write as cosine theta, or in short we say cos theta. Cos theta is adjacent side upon hypotenuse, which can be also written as, with respect to say triangle ABC, adjacent is BC and hypotenuse is AC, which can be also written as x upon r. So this is the trigonometric ratio cos theta. Here these are the measurements of the sides. BC, AC or X or R, they are the measurement of the side. BC is the length of side BC. AB means the length of side AB. AC means the length of side AC. Now the second one, sine theta. Sine theta is opposite side upon hypotenuse. Now opposite side here in this triangle is AB upon AC. AC is hypotenuse. AB we write it as y upon r. So we can write like this also. Then we write tangent theta or tan theta. Tan theta is opposite upon adjacent. Tan theta is opposite upon adjacent. Opposite is y, that is y upon adjacent is x. Opposite side AB and adjacent is BC. So we can write tan theta in this form. Tan theta can also be written as sine theta upon cos theta. Now you may think, how do we get this sine theta upon cos theta? So I help you to get you understand. Say I am having tan theta is y upon x, I divide numerator and denominator by r. That means y divided by r, x divided by r. Now y divided by r, I am having sine theta, and x divided by r, I am having cos theta, you can see. So with the help of that, I can put here sine theta upon cos theta. So tan theta can also be written as sine theta upon cos theta. Now I am having the main basic trigonometric ratios. From this basic trigonometric ratios, we can have other ratios. That is, from cos I can get sec theta. Sec theta is inverse of cos. Sec theta is inverse of cos. That means I have to invert this. That is hypotenuse upon adjacent. Now hypotenuse is AC and adjacent is BC. That is R upon X. So from cos I have got sec. From sine I will get cosec. So cosec theta equals to hypotenuse upon opposite. You can see the inverse of this, which is AC upon adjacent. Opposite is AB, sorry, which is R upon Y. Now as we have got tan theta, we can find out cot also. So from this I will get cotangent or cot theta. Cot theta equals to adjacent upon opposite side. Adjacent is BC, opposite is AB, which can be written as x upon y. As we have understood of tan theta, it can be written, cot theta can also be written as cot theta, can also be written as cos theta upon sine theta. Same type of argument I can get, that is cot theta is x upon y. I divide it by r, numerator and denominator. So x upon r, y upon r. X upon r is cos and y upon r is sine. So cot theta is cos upon sine theta. Now once again I write the trigonometric ratios, and then we learn something more about it. So cos theta equals to x upon r sine theta, y upon r tan theta, y upon x, right? Now the inverse of this sec theta, r upon x, cosec theta, r upon y, cot theta, x upon y. Now as I have written that they are inverse of each other, so from that we get some different type of formulas. Say cos theta can be written as 1 upon sec theta, or you can write sec theta equals to 1 upon cos theta. Further, using these two together, if I multiply sec here, then cos theta into sec theta equals to 1. So you get a simple formula like cos theta into sec theta is 1. Similarly for sine theta is 1 upon cosec theta, or cosec theta equals to 1 upon sine theta. Cross multiplying sine theta into cosec theta is 1. Wait. Now, with respect to tan theta is 1 upon cot theta, or cot theta equals to 1 upon tan theta. Now I multiply cot with tan theta into cot theta is 1. That means cos and sec are inverse of each other, sine and cosec are inverse of each other, tan and cot are inverse of each other. Now as I said, Pythagoras theorem, right angle triangle, and with the help of that we can find out something. So once again I try that. So right angle triangle, ABC, easy to understand. If this is theta, this is x, this is y, this is r. Now Pythagoras theorem, as we know, the square of sum of side of triangle is equals to the square of hypotenuse. That is AB square plus BC square equals to AC square. This is Pythagoras theorem. Now AB square is 5, so we can write y square plus x square equals to r square. Now, as it is an addition, we can write x square plus y square. X square plus y square equals to r square. All are same thing, right? Now from this, if I divide this equation with r square, that is all the three terms are divided by r square. What do we get? Divide by r square. Therefore, x square upon r square plus y square upon r square equals to r square upon r square. R square upon r square is 1. This can be written as x upon r whole square plus y upon r whole square equals to 1. Now x upon r, we have cos. So it can be written as cos square theta plus y upon r is sine theta. So sine square theta equals to 1. So you get an identity of trigonometry. So this is trigonometric identity, the main basic identity of trigonometry. Now with respect to this trigonometric identity, we can have all other different trigonometric identities. Let us see after this. Now the basic identity, cos square theta plus sine square theta equals to 1. Now from this I can interchange and get other identities like, so if I take sine square on the other side, so cos square theta equals to 1 minus sine square theta. Now instead of taking sine square, if I have taken cos, then I will get sine square theta equals to 1 minus cos square theta. So we are having three identities. From main identity I have derived 2. So total 3 identities I am having. I hope everyone remembers what is an identity. Identity means which is true for all values of theta. It is true for all values of theta, then it is called an identity, otherwise not, otherwise it is a formula. It is an identity. Now from this main identity, we find out other identity. So once again I write cos square theta plus sine square theta equals to 1. Now I divide this identity by cos square theta. So divide by cos square theta. So you will get cos square theta upon cos square theta plus sine square theta upon cos square theta equals to 1 upon cos square theta. This get cancelled. Now, if it cancels, it is 1. Sine upon cos, as we have studied, it is 10. So it is 10 square theta. And 1 upon cos is sec. So sec square theta. Now if I rearrange this, it will look like this. Sec square theta equals to, sec square theta minus tan square theta equals to 1. So you get an identity normally used in this form. Sec square theta minus tan square theta is 1. Now here I have written sec square is equals to that. I recopy it. So sec square theta equals to 1 plus tan square theta, or if I take tan on the other side, I will get this identity. Now tan square theta. Tan square theta equals to sec square theta minus 1. So this is how we can get the other identity. So again I have derived, or I have found 3 other identities. So this 3, another 3. Further again I take the main identity and get the other one. So cos square theta plus sine square theta equals to 1. Now divide by sine square theta. That is, all the terms are to be divided by sine square theta. That is cos square theta upon sine square theta plus sine square theta upon sine square theta equals to 1 upon sine square theta. Now sine and sine get cancelled, so it is 1. Cos upon sine is cot. So cot square theta plus 1 equals to 1 upon sine is cosec square theta. Rearranging it, I will get cosec square theta minus cot square theta equals to 1. So you get an identity. Now I rearrange it. Cosec square theta, I take cot on the other side, so it becomes 1 plus cot square theta, an identity. Then I write down cot square theta. Cot square theta equals to cosec square theta minus 1. So you have another set of identities. So we have got total 9 identities. This is one set. You can say one set of identity. This is another set of identity. Right? And one more set of identity. So if you remember this set of identities, then our trigonometric sums, which we will be having, they will become easier. We can apply this all identities, formulas, conversion and everything, so that our sums becomes easy. Now sometimes it happens that we don't remember the ratios. That is, cos theta is x upon r or y upon r, whatever. We forget. So there is a trick. If you remember a sentence which I am giving, then it will become easier for you to remember. Now, before writing that sentence, or before writing that, let us understand triangle once again. This is right angle triangle. Call it as ABC. Right? And this is perpendicular. Right? Or sometimes it is called height also. This is hypotenuse. And this is side. Right? Now, I will write down something, a sentence. Try to remember. Some people have. Some people have curly brown hair, turned permanently black. Right? Now, what does this give? Some people have curly brown hair turned permanently black. Now, the side can also be called as base. Right? Now, just see. First one gives us sine theta, the ratio of sine. How? S equals to. So, from this I write S equals to P upon H. P upon H. Right? If this is my theta, opposite, as you remember, opposite. This is adjacent. P means perpendicular, H means hypotenuse. Right? Perpendicular upon hypotenuse, or X opposite upon hypotenuse. Right? You can say opposite upon hypotenuse also, or Y by R. Then curly brown hair. This is cos C. C equals to B upon H. B means base. Base means side, adjacent. Can be called as adjacent upon hypotenuse. That is X upon R. Right. Third one, tan theta. So tan equals to P upon B. P means perpendicular upon base. Perpendicular is, that is, you can also call it as opposite. Opposite upon adjacent. That is Y upon X. So this is how you can remember the ratios. This is one way. There are many other ways. So this is one of the way I am explaining to you to remember the trigonometric ratios. So sine, cos and tan can be remembered in this way. Some people have curly brown hair turned permanently black. This is to be remembered. Right? This gives you the formula. That is the ratios. I hope you have understood almost everything, whatever I have tried to explain to you. If you have understood, the simple thing is you have to practice it. Without practice, you are not going to understand. You cannot remember all such things. So have a practice, and after doing practice, you will know trigonometry. It is really very simple, easy chapter or easy topic to understand. Now, simple thing, subscribe my channel. You will have notifications. So enjoy it. Thank you very much.